guys, you need to understand what you're doing. I found people when they are asked to prove that lines are parallel, they use the distance formula. For what? The distance is for calculating the length of a line. Now, when they ask you to prove that lines are parallel or they are perpendicular, I emphasize that you only look at the gradient. You calculate the gradient of those two lines. Now, the distance is just about the length. How long is it? How far is it? That is the distance. You can't use the distance to calculate to check if lines are actually parallel or if lines are perpendicular or if lines are collinear. I gave you the formulas that you need to use to prove that that applies. Okay, the distance between 2 points may never be negative. If you're doing physics, you will know that the distance may never be negative, and this is the distance formula that you need to be using. We use this when we prove that lines are actually the lengths of the lines, whether lines are equal or not. It's not about proving whether lines are parallel or not, or proving whether lines are perpendicular or not, or proving that lines are collinear. All right, it's not about that. Okay. Now, calculating the distance between these 2 points, you will simply find the square root. AB will be equal to the square root of YA minus YB divided, you add them, you square them, plus XA, which is 1, minus X of B, which is negative 3, and you square that. Okay, now this is what we're going to have. You can just put that in your calculator, whatever is inside the bracket, and it'll give you 16 plus 60, which is equals to square root of 32. It tells me that the length of AB is square root of 32. Now let's calculate the distance here. It'll simply be 3 minus 1 squared, and you will add that with 1 minus 2, and you're going to square that. Obviously, it'll give you 2 squared plus negative 1 squared, and that will give you 4 plus 1. 4 plus 1 will simply be square root of 5. Here you do the same thing. I'm not going to repeat what I've already discussed, because now I'm going to be saying the same thing over and over again. Now, when they talk about determining the perimeter, you will have to calculate the lengths of all the sides of this triangle. When they talk about proving that whether it's a right angle triangle or not, you can actually prove whether one of the lines are perpendicular or not by calculating the gradients and multiplying the gradients together. And if you get -1, it means that those lines are parallel. Or you can simply use whatever you got in A when you calculated the perimeter. If one side is squared is equal to the sum of the other side of sum of the squared of the other side, then you can know that that is a theorem of Pythagoras. It will tell you that that is a right angle triangle by taking the longest side, that is. Now here all I did was just to calculate the length of PQ, and then I calculated the length of PR, and then I calculated the length of QR, and I took the longest side and I tried to calculate the longest side, which is PR, and by taking PQ squared plus QR squared, which is simply the theorem of Pythagoras, and that gave me square root of 65. And obviously I tried the other one and it gave me 7, and I tried QR, it gave me 3 square root of 5. Now what I'm going to do is simply say QR squared. what is QR? You realize that QR is 3 square root 5. You're going to square that. It must be equal to 60 square root of 65 squared plus 7 squared, which is simply PR plus QP squared. Okay, so basically what I did was just to take QR will be equals to PR squared plus QP squared. And you realize that QP is equals to 2 square root of 5. And you realize that this is actually not a right angled triangle, because whatever I try to do, it simply is not working at all. Okay, the longest side squared must be equal to the sum of the other sides squared, and that is not the case in this scenario. Okay, now I'm mixing things up. Let me just restart this.